Hey everybody, so today we're going to talk about how to find the volume of prisms and cylinders. So the best way to think about volume is like how much stuff you can put inside of something. So if we were going to like fill this up with water or sand or whatever, it's the volume is telling us how much we can fit in something. So we're talking about the inside. Where surface area, we were talking about the outside of the shape. Now we're concerned about the inside as well. So the first one we're going to talk about is the volume of specifically a rectangular prism. So this one is, technically it's a square as a base, but a square is technically a rectangle, right? So if it's rectangular, if it's got square or rectangular bases, that's what is considered to be a rectangular prism. So the volume of that is your length times width times height. So in this case, you've got 4 times 4 times 10, which is going to give you 160. Okay, so this is one that you all are familiar with, especially my 9th graders. You guys have just done this in our density lesson a couple weeks ago because of spring break now. So this one I believe you all should be familiar with, right? In 10th grade, you guys did this with me in physical science last year. I know it's been a while, but so that's how you find the volume of a rectangular prism. Okay, so now when you're finding the volume of any other prism, the volume is the area of the base multiplied by the height of the prism. So no more lateral two-part stuff. It's just you have to find the area of the base like you had to do before and then multiply it by the height of the prism. Now, it doesn't matter if your prisms are slanted, whatever. Again, it's the distance between the bases, and your height needs to be a right angle. All right, so you need to make sure that that's what you're using. We're not using a slant height. We're just using the distance between the bases. So like if we had one end flat on the ground, and how we would measure from the ground to how far up the other one is. So area of the base, this is a regular pentagon. I had to add in the apothem, and I'll make sure on the homework that you guys have the apothem for all of the ones you need. So the area of that regular hexagon is 1/2 apothem perimeter. So we've got 1/2 times 5.1, and the side length is 6, and there are 6 sides, so our perimeter is going to be 36. So then you're going to multiply those things together, and that will give you 91.8. Right, so that's your area of the base. So that gave us this area here, right, of one of the bases. Right, you only need it for one. You don't have to multiply it by 2, just the area of the base. And then we're going to multiply it by the height of the prism. So, still have the highlighter. So we're going to do volume is 91.8 times 24. And that's going to give us 2,203.2 millimeters cubed would be our units for that. Okay, and now to find the volume of a cylinder. So similar, or really it's exactly the same as finding the volume of a prism. It's area of the base, which is always going to be a circle for a cylinder, times the height of the cylinder. So we can just do pi r squared times the height of the cylinder. So volume, you can really do it in all one step. So we have pi times the radius, which is 5 squared, times 12. So that's going to be pi times 25 times 12. So you can write it as 300 pi, or if you just multiply it all out, which I think is what your Desmos calculators do for you, that should give you 942. I just plugged it in with 3.14. If you use the pi button, you might get a couple extra decimal places. So about 942 inches cubed. Okay, so like I said, volume is a lot more straightforward and a little bit faster to solve for than surface area. Let me know if you all have any questions. Remember to post in the discussion with one thing that you've learned or something that you have a question about, because this week you're getting just an overall discussion grade for participating on LMS.